30?
Yeah.
Well, 10 and 15, their least common multiple would be 30. Their least common factor is 5. But see, if I just went through and multiplied each of these by 5, 5 over 10 would leave me with a number in the denominator. Remember, the whole point is I want to get rid of the denominators. Okay? So let's look at number 2. It takes Chelsea 8 hours to pick 40 bushels of apples. Jack can pick the same amount in 10 hours. If they work together, how long would it take them? So 1 over individual plus 1 over individual. They're both in hours, so we're good there. Is equal to 1 over together. Let's see here in this problem, LCD would be 40x. So 40 over 8 is 5, so we have 5x plus 40 over 10 is 4. 4x is equal to, and the last one, the x's cancel, is equal to 40. So we've got 9x is equal to 40. So let's see here, we're going to get a little fraction going over here. 40 divided by 9 is, 4.44. Yeah, we'll just have to go with that. Okay, 4.44 hours. Okay, number 3. Norachai, I guess is that name there, can harvest the field in 12 hours. One day his friend Ryan helped him and it only took 6.86 hours. Find out how long it would take Ryan to do it alone. So this one, same idea, but it manipulates it just a little bit. We don't know how long it takes Ryan. So we've got 1 over 12 plus 1 over x is equal to 1 over 6.86. Now, I don't know about you, but I really don't know what the least common multiple between 12 and 6.86 is. So I'm going to let my calculator help me out on this one a little bit. Just a slightly different way of looking at this. I'm going to subtract the 1/12 to the other side. And I'm going to let my calculator handle that. 1 over 6.86 minus 1 over 12, and I'm really, really hoping that it'll turn this into a fraction. Okay, good, it does. 257 over 4,116. Okay, so what am I going to do at this point? Cross multiply. Cross multiply. Okay, so we have 1 times 4,116 is equal to 257 times x, and then divide by the 257. Okay, in other words, it just flips that fraction over. So 4,116 divided by 257 is approximately a little bit more than 16.02 hours. So about 16 hours. Just about. Okay, let's do another one like that just to make sure we've got it. Working together, Scott and Paul can pick 40 bushels of apples in 5.32 hours. So that's the together time, 1 over 5.32. Had he done it alone, it would have taken Paul 13 hours, so 1 over 13 plus 1 over Scott's time. I'm going to do it the same way. I'm going to subtract the 1 over 13. Let my calculator handle that. 1 over 5.32 minus 1 over 13. So 1 over x is equal to 192 over 1,729. If we cross multiply and then divide to solve, it's just going to flip that fraction over. So it's 1,729 divided by 192. So right at 9 hours. Okay, approximately 9 hours. And you can always check that. Okay, go back to the beginning. 1 over individual plus 1 over individual is equal to 1 over together. So 1 divided by that number gives you the 5.32. Okay. So that's one way to check. So these are pretty easy. You just got to remember the setup. Now the mixture problems, not saying that they're not easy, they're just a little bit, you got to learn the setup to these two, okay? So let's look at number 15. Number 15. 2 cubic meters of sand was mixed into 6 cubic meters of soil containing 40% sand. What is the sand content of the mixture? So let's think about this for a second. We've got 2 cubic meters of just sand. We have 6 cubic meters, and it has 40% sand. How do we find out how much sand is in that 6 cubic meters? How would we find out how much? Yes. Okay. You don't have to worry about cubing the 6. Okay, that's just the units. Okay. Yep. Okay. Multiply 6 times 0.4. That's going to give you how much sand. It's 40% of the 6 cubic meters is sand. Okay, so if we're going to set this problem up, we have 2 cubic meters of sand plus 0.4 times 6 cubic meters over how many cubic meters do we have in total? 8. Okay, so over 2 plus 6. And that is going to equal our amount, or the sand content. Okay, so we've got 2.4 plus 2 out of, so 4.4 cubic meters of sand out of the total 8 is 0.55. So this is 55% sand. Okay, so what you're doing is you're figuring out, well, how much sand do I have out of my total mixture? Okay, part out of the whole, essentially. Let's look at another twist on this. Rob wants to make a 46% sugar solution. So he wants it to end up being 46%. He has already poured 8 gallons of a 30% sugar solution into a beaker. How many gallons of a 78% sugar solution must he add to this to create the desired mixture? So we've got 8 gallons at 30%, so 8 times 0.3. Plus how many gallons, we don't know, x times 0.78, because it was 78%. So our total measurement here, we've got 8 gallons plus, we don't know how many gallons, so 8 plus x here has got to equal, we want it to be 46% sugar, so convert that percent to a decimal. So kind of a rational equation here, we just don't have a fraction on the right side, but that's okay. Technically, if you really want to get in that frame of mind, just put it over 1. So if you cross multiply, you've got 1 times the stuff that's on top, so 8 times 0.3 is 2.4 plus 0.78x is equal to, we need to multiply the 0.46 times 8 plus x. So we need to distribute. 0.46 times 8 is 3.68, and we have 0.46x. It's just a linear equation. 0.78 is bigger than 0.46, so I'm going to subtract the 0.46x and subtract the 2.4. So we have what? 0.32x is equal to 1.28. And then divide by the 0.32. So 1.28 divided by 0.32 is 4. Check it. We had 8 gallons of the 30% plus 4 gallons of the 78%. And we had 8 gallons plus 4, so 12 total gallons, 46% sugar. So 4 gallons. That one is honestly the most complicated one, trying to figure out how much you need to add in there. So look at number 17. Beth mixed together 3 gallons of brand A fruit drink and 8.5 gallons of brand B fruit drink, which contains 44% fruit juice. Find the percent of the fruit juice in brand A if the mixture contained 38% fruit juice. So we've got 3 gallons. We don't know its concentration. So 3 times X. Plus 8.5 gallons, its concentration is 0.44. Over total gallons, 3 plus 8.5. You can go ahead and add that number. I'm just writing it out so you'll know when you look back where it came from. Is equal to, the mixture was 38%, so it's equal to 0.38. So we're going to have 0.38 times 11.5. Lots of decimals here. So we have 3x plus 3.74 is equal to 4.37. So subtract the 3.74 and divide by 3. It's 0.21. X is equal to 0.21. So X was referring to a concentration. Convert that to a percent. 21% fruit juice in brand A. Okay, one more of this type. Let's talk about mixing metals. Metallurgist needs to make 6 kilograms of an alloy containing 12% silver. She's going to melt and combine one metal that is 4% silver with pure silver. How much of each should she use? Okay. So let's set this up like we normally would. She's going to combine 4% silver. We don't know how much, so 0.04 times X, plus pure silver. Pure silver would be 100% silver, so 100% as a decimal is 1. We don't know how much, but we can't use X, because X was how much of the 4% we were using. We're probably not going to use the same amounts, so we need a different variable. So that's why. Over total. Well, X plus Y. However much we use of the 4% plus however much we used of the pure silver equals, oh, excuse me, hang on. We know that part. It's 6 kilograms. Sorry, she's making 6 kilograms of an alloy. So the X plus Y, is really 6. We do know that part. And it will be 12%. Okay, so we got that much. Now, we can start solving this, right? We can multiply 6 times 0.12, and that's 0.72. But the problem is we have 2 variables. So anytime we have 2 variables, that must mean that we need 2 equations. So the other equation is that X plus Y is 6. however much we use of the 4% metal plus however much we use of the pure silver is equal to 6, because we know that we are making 6 total kilograms. Now, it doesn't matter which one you solve for here. I would solve for y, because when I look at my other equation, the y doesn't have a coefficient, so that just means less distributing and opportunities to mess up. So if I solve for y, I subtract the x from both sides. So I substitute. Okay, y is equal to 6 minus x. So I replace y in my equation with 6 minus x. So let's see here. We need to combine our x's on this side right here. 0.04 minus 1 is negative 0.96x. And I'm going to move that 6 to the other side. So 0.72 minus 6 is negative 5.28. And then divide by the negative 0.96. So 5.5 is my x. So that means that my y is 0.5. And I just need to go back to my original problem and notice that x was being multiplied by the 0.04. So I need 5.5 kilograms of the 4% alloy and half a kilogram of the pure silver. I would encourage you, when you get to the end here, check it. Okay, 0.04 times 5.5 plus 0.5 divided by 6 is 0.12, which is 12%. Okay. So this one and the second one are the most involved types of problems.